Hey guys, welcome back again. Today we're going to move on, instead of direct proportions, which we did in the last video, sorry, I'll enunciate, we're going to look at partitive proportions, or proportions by part. The trick between knowing which one you have to use is you have to look at the information you're given. In the previous ones that we were doing with direct proportions, we were giving part to part and part to part. And this one, what you'll notice, is they've given us a whole, part to whole. So these we're going to set up a little different. We're going to set it up as part to whole. So I started out here with a problem because there's not really any definition. So I'm just kind of going to show you how to do it by a problem. And I'll show you, I did it with a chart, which is a very time-consuming way to do it, especially when you start dealing with bigger numbers, which is why we're going to use proportions. But just to kind of get the idea here, I've shown you both ways. So our problem says, Sierra and James were running for class president. For every 5 votes Sierra received, James got 3. So we see that we have a ratio. For every 5 votes Sierra's got, James got 3. If we were setting it up as part to part like we've been doing, it'd be a 5 to 3 ratio. However, when we read further, we're going to realize that we're going to have to look at this a little differently. So if 32 kids voted, meaning in total, so now I have a total. Out of all the kids who could vote, out of the entire class, 32 kids voted. So how many votes did each person get? Well, we're still setting up our proportions similar to what we did before, except now we have to do part to whole. Because I have the total number, and I want to know, out of those 32, how many voted for Sierra, how many voted for James. So here what I've done is, we could think through it logically and create a chart. So I made a chart for James and Sierra. So for every 5 Sierra gets, James gets 3. So I just filled it in. 3 and 5, so that was 8 kids in that column. So then we just do another one. That means there's 16 people who voted. 3 to 5, that means there's 24 people who voted. 3 to 5 again, that means 32 kids voted. Then I can add up my rows. That means James got 12, Sierra got 20. All right, now that worked for this one. The chart wasn't too big. However, if we start dealing with giant numbers, if I told you that it was 1,032 kids who voted, you're not going to want to make a chart and try to figure out how many times you have to do that to get up to 1,032. So to make it easier on ourselves, we're going to set it up as a proportion. So here what you notice is we're going to set it up as part to whole over part to whole. So what I mean by that is the first thing I want to look at is for every 5 votes Sierra received, James got 3. So altogether that's 8 votes that were cast. So part to whole, I'm going to look at Sierra's part. Sierra's votes, which was 5, out of the total number of votes, which would be 8. Both Sierra's and James' votes is 8. So every 5 out of every 8 votes went to Sierra. That's why we're writing it that way. It's a little bit more like a probability when we write it that way. So part to whole. 5 out of 8 votes go to Sierra, part to whole. I've told you in total there's 32 kids, so that's the whole number of votes. I want to figure out what part of that vote went to Sierra. So that's why the X is there. So this is how I would set up my proportion. And then from here, if you'll recall, we just cross multiply and then solve our equation to get our answer. So what I would do here is I would take 5 times 32, 8 times x, and you know what, I can write that out for you here. So I wind up with 8 times x is equal to 5 times 32, which is 160. Then I could solve for x, and I would find out that Sierra's part of the vote was 20. So I can use proportions to find the same thing out. That tells me how many were Sierra's. Now if I want to know how many were James', I can go back. Well, there were 32 total votes. If 20 of them went to Sierra, I can subtract my 2 numbers and find out that Sierra got 20 and James got 12. So then all I would do after I figure out the 1, go back, subtract it from my original total to get the total of my second one. So we could do it with a chart, but like I said, that can get very time consuming. So we want to use proportions. So here, remember, it's a part to whole, not a part to part like what we were doing with direct proportions. So we're going to do some more examples here. Melody mixes 5 quarts of yellow, 2 quarts of orange, and 1 quart of white paint. So what you'll notice here is I actually have 3 different numbers. 5 to 2 to 1 white. I have 3 different parts I need to figure out. So this means it's going to be a multi-step problem, but that's okay, it's not a problem. if she wants to make 16 quarts of this mixture, how many of each color does she need? So remember, when we're setting it up, it's going to be part to whole. Well, I know total she wants 16 quarts of all of the paint. So I need to figure out what portion each color is. So I'm just going to start with yellow. I know she uses 5 quarts of yellow to every how many quarts? There's 5 quarts when she mixes 8 quarts together. There's 5 and 2 and 1, okay? So I have to add all those together for my whole. So there's 8 quarts of paint. Out of those 8 quarts, 5 of them are yellow. So when I solve this one, it's going to give me my answer for how many quarts of yellow she needs. So again, we're going to cross multiply. Sorry, let me switch color. I just like to color code it when I make my little arrows here. Here I wind up with 8 times x. 5 times 16 gives me 80. Sorry, gotta remember which color I'm using. 80. Now to solve for my unknown, to solve for x, I'm just going to solve my equation, and I find out that it is 10. So I know, and I'm just going to start my answer over here, that I need 10 quarts of yellow. Am I done? No, because I want to know how many quarts of each color I need. So that was one step. I figured out how much yellow I need. So the next one I'm going to do is I'm going to figure out how much orange I need, because that was the next one that I needed. So it tells me 2 quarts out of every 8, altogether there's 8 quarts, 2 of them are orange. So how many would that be if I have 16 quarts? We'll use our cross multiplication to figure it out. So here I get 2 times 16, which is 32. Over here I have 8 times x. Again, I'm going to solve my equation, and I find out that x is equal to 4. So I need 4 quarts of orange. Now from here, there's 2 ways I can go about getting my last number. I can set up my proportion again, or I can look at these 2 numbers. Together this is 14. I know that I need 16 total. So when I subtract my 14 from 16, that means I need 2 quarts of white. All right, that's the easiest way to find that last number, but if you want, I'll show you how we can set it up just to practice with our proportions again. So for white, I said there was 1 out of every 8 was white. So how many is that out of 16? And we would just go about solving it the same way that we were solving our other ones with our cross multiplication. So there I get 16, here I get 8x, and then when I solve, I find out that indeed 2 quarts would be white. But really, once it comes down to that last one, it's easiest to just use subtraction to find it, and then you don't have to set up another proportion. All right, so let's take a look at another one. So here we have some people driving across the country. Mr. and Mrs. Russell shared the driving during a trip across the country. For every 15 miles Mrs. Russell drove, Mr. Russell drove 20. So altogether, that means out of every 35 miles they travel, Mrs. Russell is driving 15 of them. So I'm going to solve for Mrs. Russell's first. So he drives 20, she drives 15. Just look at that first leg. You can kind of even map it out if you want. So here's Mrs. Russell, she drove 15, and then Mr. Russell took over and drove 20 more miles. So altogether, that means they've traveled 35 miles, so part to whole. So I'm going to look at this orange part, Mrs. Russell's part. So she drives 15 out of every 35 miles. So if their total distance is 2,800 miles, how many of those miles did each person drive? So I'm going to have 2 answers. So over here, I'm going to write Mrs. and Mr. The first one we're solving for is how far Mrs. Russell has driven. So I'm going to use my cross products, and I'm definitely using my calculator here. side, I get 35x. So then how am I getting x by itself? We're just going to solve the way we've been doing. And again, if this is confusing, go ahead, rewatch the previous videos to help you get there. And when I do this division, I find out that Mrs. Russell drove 1,200 miles. Now, to save myself time so I don't have to set up and solve another proportion, I know the total distance was 2,800, so anything that Mrs. Russell didn't drive, Mr. Russell must have. So I can just subtract those two values to get my second answer, rather than going through the process of setting up another proportion. So then I find that Mr. Russell drove 1,600 miles, while Mrs. Russell drove 1,200 miles. All right. So it's just a big matter of this one is making sure you're setting it up right, and then it's just back to solving the proportions, which you're all very good at. So if you have any questions, please, I encourage you to rewatch any of the videos that you need to. Post your questions in the comments, email me, ask them in class. I'm happy to answer them whenever you need me to. So you guys have a great night.